Okay, you got to prepare for this one. So what we have is we have a big radical expression. We have negative square root of 27 plus 2 square root of 27 plus 3 square root of 48 plus 3 square root of 45. So what I want to do when solving a problem like this is I got to remember that I can only add and subtract radical expressions when I have like terms. Now, I have like terms here, square root of 27, square root of 27, but I guarantee I'm going to have more like terms when I simplify square root of 48 and simplify square root of 45. It's also understood that I can also simplify square root of 27. So when I have a problem like this where I have so many different terms, I'm going to simplify everything and then kind of see what I have at the end, and then all my like terms at the end I'm going to simplify, or I'm going to, combine. So the first thing I'm going to look at is how can I simplify the square root of 27? Well, just to go over, just to remind you again, we can always simplify our square roots by remembering that we can take the square root of our square numbers, which are 4, 9, 16, 25. So I want to see, can I write each one of the square root of each one of these numbers as a multiple of one of the square numbers? And you can see that I can rewrite square root of 27 as 9 times 3. So I'm going to do that for both of them. I can rewrite the square root of 48. Now, I know it is divisible by 4. I know it's divisible by 8. But you want to say, by 8. But you want to write in what is the largest square number that goes into 48. Well, I can rewrite that as 3 times 16 times 3 plus 3 square root of 45 can be rewritten as 9 times 5. All right. So now what I've done is I've not changed this mathematically. It looks a little different, but each one of these numbers still represents the same number in the square root. However, by now applying the rules of my radical expressions, I can now separate these and take the square root of the numbers I know. So I can take the square root of 9, which we know is going to provide us with a negative 3. And since I cannot take an even root of square 3, I'm going to leave it under the radical. Plus 2 times square root of 3 again would be 3. Radical 3 plus 3 square root of 16 is 4. Radical 3 plus 3 times radical 3 square root of 5. Because the square root of 9 is 3. And since there's no even root for 5, I'm going to leave it on the outside. Now what we notice is I have 3 square root of 3's. Meaning I can combine them. I'm adding and adding them. But before I do that, I need to make sure I simplify what's being multiplied by each radical. So I have negative 3 square root of 3 plus 6 square root of 3 plus 12 square root of 3 plus 9 square root of 5. Now, since the square root of 5 is not the same as the square root of 3, they're not like terms, I can't combine them. So that's going to be left all by its own. But I can combine a negative 3 square root of 3 plus 6 square root of 3 plus 12 square root of 3. And since they're like terms, just think of it as like, oranges. Negative 3 oranges plus 6 oranges plus 12 oranges. You're end up going to have a positive 15 square root of 3 plus 9 square root of 5. And since these are not like terms, this is my simplified version of this big radical expression. There you go. Thanks.